In this tutorial we will see how we can implement custom object detection using YOLO version 8. So for this we will start with a new virtual environment setup. We will work with Python 3.10.1. We will use labelImg to prepare our dataset, especially for annotations, and that is also called labeling our object. And after that we will use YOLO8 from Ultralytics to train our model, and finally end with testing the model. So if we looked at the expected outcome is the following. So we expect our custom object, in this case is a bollard, to be detected by using YOLO version 8. Yeah, then let's get started with our environment setup. So first of all, what we have to do is to create a virtual environment where we want to set up our dependencies for YOLO version 8. So let's get started. So in order to create our virtual environment, what I really do is like I have a folder with virtual environment, a folder named Python virtual environment, and where I make all the virtual environment in this folder. So I keep all the virtual environment localized to one folder. If you haven't seen about the details of this virtual environment, I would ask you to go and see my previous video. So we can create here. So we open a vscode in this folder. So just ignore this for a moment. Yeah, and then so we would want to switch to command prompt, and we are already in our Python virtual environment. So we create a virtual environment in this folder. So it's Python so we can tell it custom YOLOv8. And hit enter. So it will take a while to create a virtual environment. So I pause the video, and when it's done I'll be back. Yeah, so now we have our custom YOLO version 8 folder, and you would want to check the Python environment here. So it's 3.10.1, and normally if you have multiple versions of your Python installed, so it depends upon what Python is going to be used depends upon this path. So if you could go to the path and see here my Python version 3.10.1, I have multiple Python version 3.10 and 3.9. so you would want to only the Python version that's on the top of the list will be installed. If you have Python 3.9 on the first, so it will be by default 3.9. so make sure that in the path you have this folder on the top, so that you have Python 3.10 installed on your computer. So that was just a sanity check, and then if everything is fine, if you have Python 3.10 installed on the computer, then you are ready to go. So to activate, and now we need to activate this environment. So what we have to do is that we have to type. So we have to go to custom YOLOv8 scripts activate. So what basically we are doing is that we are going to do this Python environment scripts, and we have to activate this path here, this bat file. So this is what we are doing here, and if you are new to these activations and creating virtual environment, I would suggest you to look to my previous video. And after we hit it enter, we have our custom. Now we are inside this folder. So far all good. So now what we have to do is that create our data set. So we created our custom virtual environment. Now we have to start installing dependencies for our all the further tasks, such like dataset creations, model training, and testing. So then let's start with dataset. So now we have to prepare our dataset. We have to collect our images, and then we have to label them, and let's get started with this then. So in the folder of your choice, let's create an YOLOv8 custom object. So we create a folder, YOLOv8 custom object detection, and inside the folder we create two folder, images and labels. So in the image folder, we would want to populate this folder with the image of your interest. For example, if you want to if you want to detect an object, so whatever class of objects you want to detect it, you put it in this folder. So in this case, I'm detecting bollard, for example. So it could be any other object that you may want to detect it, and all the images goes to this folder in images. So this is our root structure, root folder, and here you have image and label. So in the image put all the images in this one, and all the label goes to this one. So in order to create a label, we have to install labelImg. So make sure you are in vscode with a custom virtual 8 custom YOLO version 8 activated, and now we go pip install. So this installs labelImg on your computer. So I already have a version of the labelImg installed on my computer, but we can do it again. So it will take a while, and once it's I'll be back when it's done installation. Yes, you see that we have our labelImg installed, but I think this is for the pip. You can ignore the warning. So to start, let's start labelImg. And you should choose open directory and give it a path where you have your image installed on your computer. So just copy and paste the path where you had your image. So just select this folder, and then file, change the save directory. So this is the directory where you store the label. So again this one, and select labels, and now you are ready to label your image. And before labeling, make sure that it's changed to YOLO. So we have different kinds of labeling format, but we would want to have it YOLO. Make sure you change it to YOLO, and then we create a rectangular box. So if we yes, this is the problem here. So when you have 3.10.1, the labelImg has some bug, and it works well up to 3.9, but if you are trying to use 3.9 and above, there is a problem with this labelImg, and so we're gonna fix it now. So in order to fix this, I'm taking this help from GitHub, and we're gonna follow this solution. So this has already, I have tested this and it has worked. So what it says is that there is a problem with the float to int conversion in this. So what we have to do is that we have to go to canvas.py in our virtual environment. So so we go to virtual environment, so custom YOLO version 8 that we just created. So we go to scripts, and so 310 lib site packages. So we have to open this file located at this path. So So our label image just crashed, and that's problem because of the float to int conversion. So we will have to take care and do some changes. There are few changes that we have to do it, and the solution that I got it from was from this kit. I will leave the link in the description. So let's get started with this. So first of all, we have to open our canvas file. So we go to virtual environment that we created, lib, site packages, libs, and we should have canvas.py. Yeah, and then we have to go to line 526 and make it int. So what basically we are doing is that we are converting from float to integer. And similarly at line 530 we're gonna change it to integer. Similarly 31, so I'm not doing anything special. I just got this help from the git, and I'm just following the instructions. So once you have done it, you save it, and we would also want to open another file that's at labelImg.py. That's site packages, labelImg.py. And we change it here to 965. So this line, so we're gonna just make this integer. And save it. So now if we run our vscode, it should be labelImg should not throw exception. So this is only with 3.9 3.10 and above. If you're working below 3.9, it should be fine. So now let's run labelImg. So again we change our directory to open directory where is the location of our images. So our images are located at, so give a path to your images, yes, and then again file, change save directory where you want to save the labels at other base and label. And now again change this to YOLO, and now we should, whenever you see this arrow coming in, that means it's good to go, and then you drop. So you can just label what you want to call it. We call it bollard, and hit OK. And now you can adjust it. So you can just choose it very carefully, because the accuracy of your model depends upon your labeling, how good you are at labeling. So until you save it, it's not going to save anything. So hit save, and once you hit save, now you could see in the labels you could see image 0. So now and then you have a new file created class. So this is a bollard. So if you had a multi-class object, for example you had a bollard and a bicycle, so the bicycle, if you label it, the bicycle comes here and so forth. So this classes.text consists of all the classes of in your images, and for each image you get your coordinates of your bounding box. And so now we will have to do it for all the images. So we have like 26, if I remember, yes, 24 images, and we have to do that for all of them. So when this is done, so go to next image. Again, make sure so make sure that it's YOLO format, and then we create a rectangular bounding box. So bollard, and you can just tune it and save. So you will have again you have for image one. So similarly you do it for all the other images. So we do it for all the other images, and I'll be back when we are done with this. So now we have all the images in the image folder, and label in the label folder together with class, so that we have only one object here, that's bollard. So if you had multiple objects, it would be multiple of the things here. So now this is our all images. So what we want to do is that we want to create our training folder, and val folder. So inside train, again let's create our images and labels. So I just copy this and put it in val folder. So out of this image we select some of the image for validation. So let me choose last 6. And put it in validation images. And similarly we put the label, last 6 labels. In validation labels 80, 19, 20, 21, 22, 104. So make sure that the images and the labels corresponds to each other. 80, 19, yeah. And rest of the images, sorry, so here 227, I put it in train images. So 0 to 17. So again 0 to 17. So 0 to 17, that goes to train labels. So what we have done here is that we have created our training and validation data set. And from the labels, the classes.txt, so we just copy and put it in the root folder. So we might need this later. Yeah, so now the structure is that we have our custom object detection folder. Inside the folder you have images and labels. These are your source files, I mean where you have all your images and labels. It's a good idea to keep them so that in case some of the images or labels are corrupt, you could use them. And then this is our train, val and classes. So this is our data set. So once we have done our data set, then what we can do now is that we can start preparing our model training. So to do the model training, so we should install some dependencies that we will see next. In order to start our training the model, we have to create a configuration file. For that, let's go to our root folder, create a new YAML file, and we call it custom data dot YAML file. And once you have this YAML file, we open it, and we already have this labelImg and canvas.py open, so we can just close them. And what we have to do is that we have to give the path to our train val, and then we have number of classes and their names. So this is what we have to give it. So we just copy the path for our train folder. So this path, so we just copy this path. So train, so we just copy this path, and then similarly for val, we just copy this path, and just this train becomes val. Then we have number of classes. So for the moment we have only one classes, so number of class is 1. So if you had more classes, for example you had bollard, sheep, truck, car, so it would be the number of classes that you have. So here we have only one classes, and the name, and the name goes so to get the name, so you have to open this classes.txt that was generated during labeling process, and we see here the bollard. Since we have only one class, so we have only one class, so it's bollard. So if you had more classes, it would appear sequentially. So for example, it could be car, cat, and so forth. So, and we have to place them in the sequence, so we just copy this bollard and then put it here. And if you had more classes, it would have been this one. So whatever you have the classes, and you can generalize this to, yeah. So yeah, so this is our YAML file, and we save it and we close it, or we can let it open. Yeah, so once we have this YAML file done, then now we have to install YOLO version 8 from Ultralytics. So we go pip install Ultralytics. So let me see the spell. So it's Ultralytics. So I just copy this, pip install Ultralytics, and so it will take a while installing. So when it's installed, I'll be back. Yes, we have this Ultralytics installed on our computer. So Ultralytics yes, we have Ultralytics installed on our computer. Before getting deep into Ultralytics and YOLO version 8, it's wise to look into Ultralytics. So Ultralytics has developed the YOLO v8 version for its plug and play use. So if you just install Ultralytics, it has all these dependencies, it has all these packages and APIs to train the object and to make inference and to detect everything here. So I would ask you to go to the to Ultralytics and try to explore more into this. But for the basic needs for custom training, we are happy with getting pip install Ultralytics, and it's with batteries included. We have all these high level APIs for our use. So I will leave the link of the description. I will leave the link of Ultralytics in the description below, and its Git also here. So it has included, it has all this YOLOv8 small, medium, large, and extra large, and already implemented here. So we can try each of them and see how they perform. I will leave the link of this Ultralytics GitHub also in the description. So now we are back to here. So we have Ultralytics. So by pip installing Ultralytics, you have the CPU version of the Ultralytics or YOLO version v8 installed on a computer. So we can just check that. So we go to Python and then import torch, and it's worth mentioning that this Ultralytics has implemented YOLO version in using PyTorch. So that is why we import PyTorch and then torch. Sorry. So you see here we have this 2.0.1 version with the CPU. So if you are happy with CPU and if you don't have GPU, you are good to go. But if you have a GPU, then you should go to Ultralytics Quick Start and choose. So it's choose the version that we have installed here. It's 201. So yeah, so it's 201. So we for Windows, choose your operating system, Windows. I would like to go with pip. So if you have installed Anaconda, go for this, but I have chosen pip. Language C++, CUDA 11.7. yeah, and then we can just copy this and you can exit it here. But before exiting, make sure that you choose the right version. It's 201 and it's also should be 201. So if we exit here, so we are back to v8 and just paste it. So yeah, so we can pip3 install and just upgrade. So you just type these things and then you would be working with GPU, but I don't think I have a GPU on my computer, so we can just go with CPU and that should be fine. But if you have a GPU, this is for you. So we can just yeah, so we have installed our Ultralytics that includes compute version YOLO version 8 on the computer. Now once we have Ultralytics installed on a computer, so we can train our YOLO model directly from the command line interface. So it's YOLO task is equal to mode train. So we can just train up to 25 epochs to be quick, but you need more than that to train an object. So and this data is the file that we have here, custom data.yaml. And model is equal to is YOLO 8M. So about this model 8M, so it's worth mentioning something about it. So if you go to the GitHub of Ultralytics, which I will leave in the description, so you see there are many models that has been already implemented by this Ultralytics. So you could choose small, medium, large, and Excel. So what we are doing is that we are training upon this model. So it's the trade-off between accuracy and speed. So you see here, I mean, the model parameters, our accuracy is increasing and the speed sorry, the accuracy is also increasing, but whereas the cost of speed also. So we just find a balance and we choose this YOLOv8m, and this is what v8m means, and it takes a size of 640 pixels, so that is required. So 8m, and then we have image size 640, and this comes from here. So if you are choosing v8m, so the image size is expected to be 640, so that is why we give here. And then sorry, so batch size we can choose whatever we want, but I can just leave for the moment, but if you want you can choose batch size as well. And patience 25, so patience is equal to 25. What this really patience does is that if the improvement of the loss curve is not significant, or if the loss is not decreasing significantly from 25 epochs, then it just breaks out. So there's no point in training if the loss is already converged. So this is patience 25. So you can just keep if you want to, but we can go with very simple thing. And then yeah, we can patience is, we can keep it 10. So after 10 epoch, if the loss is not significantly decreasing, we just break it, and then we just hit enter, and then it will start training. So what this will do is that this will download your YOLOv8 model and then do the transfer learning on that model. So if we go to this, we should see something here. So it would take a while. So I have an error here, let me find it out. Sorry, it should be YOLOv8m. So I can just so it's YOLOv8m. So and V was missing here. And it would take a while. Yeah, you see, it's already started to download, and it will start training. So if you could go to the folder here, you would see some files starting to download, and then it will start training. Custom data YAML. CSTMDATAYAML. Let me see. Oh, sorry, we have to go to the path. So we have to run from this path. So we would have to go to the path where about the base folder of the path. So we are now here object detection, and then we would want to run that. So we change the path, and then to the base folder here, and then we see that it already started downloading. So it's basically we have to go to the base folder, and then it has to start training. Yes, it's already downloaded, and now we are going to the transfer learning based on the weights here. So it would take a while to train it, and this is the summary of your model. It would take a while, and when it has done training, I'll be back. Yes, now the training has been completed. So you get so we we trained it for a 25 epoch with patience of 10, and then it looks like it trained for 14 epochs. So and then because I think because of the patience it was 10, and then the model while training it looked for train epochs, and if there wasn't any significant loss in the in the um, in the if there wasn't any significant decrease in the loss, so it just terminated. And then we can look into the yes, so now we can look into this run. So these runs will be created when you do the training, detect, train. Yes, and this folder consists of the weights, and then these are the labels, these are the results. So I think these two are more important, and then for us, and then the weights. So let's look into what results CSV has. So it consists of KPIs and matrices. So we trained for 14, and it has all these losses after each epoch. So it has validation and training loss. And similarly the results, I mean, this is the plot of the results that we have in this CSV file. Yeah, so this is the training and validation loss. So we haven't trained it too much, only 14 epoch, and because there were very limited data, so at least we need to have at least 1000 data for sample points. So this is what we have, and then you have these weights, and then we need is the best. So we copy this weights and put it in the base folder, and we can call it model custom bollard.pt. Yeah, so this was your base model, and based upon this model we did the transfer learning to detect our bollard. So this is the model that we need to make an inference. So and now we need to so after the training has been done, so after we have the training, and now we go to the testing part of that. And for testing part we do the following. So we can take some of the images from the validation folder. Normally it should be in the test one, so we can just take these two images, and we would like to see how it behaves on these images. And now we will do the inference or detection on this image, and we will see that if the model that we trained, model custom bollard.pt, is able to make inference on this level. And then so to make an inference, we have to we just have to pass this command. So what this command is tells us that YOLO, so YOLO task detect, you detect an object, predict, you predict, and then the model. So the model is, and you pass the name of the model that we have here, model custom bollard. So you pass so model custom bollard.pt, and then you want to show it, and you can choose the confidence 0.5 or 0.7 depending upon your use, and then you pass the source. In this case we have 19, image scale, image 19 scaled PNG, and then save text as true. So we want to save this also. So if we just run it, and it would take so save text. So there is something wrong with the save text. So should it be true? Let's see. Oh, I think there is something wrong with the syntax. I'll just, yes, sorry, it's save underscore txt is equal to true. So it's doing the inference. Yes, so now it's done. Yes, you see it's like 0.92%. Yeah, so and then if you look into this path, it says that one level saved to run, detect, predict label. So you have to go to run, detect, predict, and labels. So this all the inference is saved here. So it's 0.92%. Okay, so this is bollard. And these are the coordinates of your bounding box in YOLO format. So this gives you the normalized center, x and y coordinate of the center, and this gives you the width and height of the bounding box. Yeah, so I think so you have this class 0, but normally it should be bollard. So maybe if we train it for more epoch, then we should be getting this bollard here. And if you want to detect the images in a particular folder, say you don't want to detect 1 or 2 images, but the entire set of images from a particular folder, in that case you just give the everything remains the same. So it's model, the name of the model, so custom bollard plt. So model custom bollard pt, so true, confidence, and then you give the path of the images. So I'm giving it all the images in the validation folder. So all the images in this val folder, val images. So it should basically do on 8019. So and let's see. So this is image 1, yeah, 2, 3, and again this class 0 is because I think it's very few epochs. So maybe if you train up to 100 epoch, then we should be able to see at least 50 epochs. Yeah. So, and all these are again saved in runs, detect, see predict 2, predict 3. So it was on image 18, and this is on the all the images that we did in the validation folder. I think my Windows is dying. It has like so it's good to have a GPU on your computer to get all these things application running. Yeah, so this is what we have, detection. And then if you want to detect the on the video, so you could do that. So I'm just copying a video. Yeah, and we have this video file. This video file consists of some recordings of the the bollard. So basically what I did is that I made a video out of the images that we have in validation folder. So these are the same frames, but I converted them to a video, and then we use this for detection. So the code remains the same. You just pass the source. You just change the source to video1 dot what's the title. Yes, to detect on the video, we just keep the syntax same, and only changes is to be made to the source. So we have a video.1mp4 file here. So we're gonna detect the bollard in this video. So if you press enter, and then it should the video should show up, and the model should be able to detect the bollard in the video. So it will take a while. So I'm pausing the okay, so we need to change the the name of the model file is this one, model custom bollard. Yeah. Yeah, so now it's running here, and then we have this video shown up. Though there are only 6 images, but I think the frame rate is 30 frames per second, so there are multiple similar images in the same sequence, so you will see the changes in a while. So here we can look into this into this detection process, and yeah, so we saw there was a change in the sequence here, so this will continue, and I will pause the video and I will show you the final results at the end of the detection process. Yeah, we see now that the video has been done. So we go to runs, detect, predict, sorry, we are here, then we should go to runs, detect, predict 5, and you have a video here, so you can just have a look. So you see there the angle has been changing, and but still in all the cases it is able to detect the bollard. But I think this class 0 is because of the insufficient amount of training, and we will see that if we train long enough and then see what happens with the class. So I just move this. So this is how we saw with the video. So we can detect so in the meantime we have trained on bollard 1. This is the new model that has been trained long enough, and let's see if we detect it using this model, what do we get. So we can just detect source. We can just change the source, and we change the model. So the name was model custom bollard 1. Model custom bollard 1, sorry, model so bollard 1. So we use this confidence, and we can give the source as image 19. And see what do we get. So after, and then we go to runs, detect, predict 6, bollard 94. So that's because of insufficient number of training. So we can just check again with 18. So you have a bollard here. So if you would check again at predict 7, and we have this bollard 93. Yeah, so not to be confused, that if you bollard 1 is trained with a high number of epoch, and custom bollard is just trained with it was like 10 or 12 epochs. So I would suggest that you train up to sufficiently large number of epochs to get a good results. So this was what we have for training now. So, and I will give the link to the description here about the PyTorch, about Ultra Analytics, and it. Yeah, so far we saw our model detection on. We saw how to make an environmental setup for YOLO version 8, and we had our environmental setup with 3.10.1. We prepared our dataset and did annotation using labelImg. We trained the model, and we did the model testing from command line. Before ending, it's desirable also to work with files rather than command line, and we will see how we can do the training and model testing with standard Python files. So for that we have this test.py. So if you open this file, so whatever the command line parameter we passed here, for example, we passed here YOLO task detect mode and all those things that we passed here, that can be passed here model.predict. So we import Ultralytics, from Ultralytics we import YOLO, and then we define YOLO as our say whatever you want to choose here. So that is, say if you want to choose on .pt, so you pass the model name here. So this model name, and then you can predict source. You want to give the source, you want to show, you want to save, that means save the bounding box and the confidence. So if you just run this and then so save this, and we can just run python test.py. So we see we have our object detected here, and we could also see at runs detect predict 8. So this was the one that was detected with 8. And similarly we can also train the model using Python files. So if you open the train file, so the similarly same thing, we can change the model name, and then we can just pass this parameter. So model.train data custom batches epoch, and workers are, you can ignore this, but what really this means is that this is the number of parallel threads in which you can assign your GPU, but for our purpose we can keep this, and I would suggest that we keep into 100 epochs. Yeah, and then you can train it, and then you can get again the we set up an environment from the scratch that would enable object detection using YOLO version v8 on custom dataset. So we prepared the dataset, we did the model, and we did the testing. So hopefully you could get a grasp of what are the different aspects of custom training object, what are the steps, and you could follow along us. So hopefully you got to take away the basics of how to set up an environment for custom object detection using YOLO8 YOLO version 8. Thank you.